Since the beginning of recorded thought, man has been fascinated with the natural world. The stars above, the earth below, and perhaps most of all, the diverse and beautiful life covering our planet. And it is the dramatic battles of nature and the fiercest predators that fascinate us most. Today, we turn our attention to a deadly and vicious predator that is slightly smaller than the shark, lioness, or eagle. This is Eciton burchelli, the army ant. For Eciton burchelli, the day starts at dawn, when the ants march forth from their bivouac, a home they construct from their own bodies. They scuttle out in a dense line, splitting into smaller columns until they reach the foraging head, a swarm of ants scouring the ground for unlucky invertebrates like scorpions. They constantly rush back to their bivouac site, carrying pieces of large invertebrates and countless larvae from raided nests. By dusk, the bivouac will form again, and the ants will rest until first light. Few insects escape the grasp of these predators. They are generalists, devouring everything in their path and sweeping across the land before them like natural exterminators. So we must wonder, how do other insects persist in the presence of such a predator? One possible answer to this type of question is that when a prey population is low, the predator population decreases in response, creating a pattern of offset oscillations. At the valleys of these oscillations, the pressure of natural selection to survive predation or a prey shortage is extreme. The predator will adapt, putting pressure on the prey, and then vice versa, creating an arms race between the two species. Our story is about the arms race between Eciton burchelli and a species of termite. The setting is Corcovado National Park, located in a remote corner of Costa Rica on the Osa Peninsula. Meet Nasutotermes afredi, a common termite species in Corcovado. As we watched the fearsome swarm of ants scouring the forest floor, we were surprised, startled even, as we observed them walking past a termite nest without so much as touching it. Shouldn't something so stationary be an easy meal for the ants? Why would they avoid these seemingly innocuous herbivores? We first asked if this was just a result of the termite's protective nest. Would ants avoid exposed termites as well? Not only did the tiny termites survive the encounter, but the army ants avoided them entirely, almost as if they were afraid of them. Further tests showed us that the scent alone of these termites is enough to send the ants running. This cotton swab has crushed termites on it. So are these seemingly helpless termites actually terrifying warriors feared by all? The answer is yes and no. When we tested other ant species, one army ant species and one leafcutter ant species, we found that they do not avoid termites like Eciton burchelli, both in direct tests and cotton swab tests. Since both a closely related species and a distantly related species do not share the avoidance behavior, it is very likely that this behavior is species-specific to Eciton burchelli. This once more prompts the question, why are they scared of these termites? To answer this question, we look even closer at what happens when the two species meet. stand perfectly still, as if paralyzed. But why? It is a response that likely arises from chemicals sprayed from the front of the termite soldiers' heads. And what's more, this phenomenon too seems to be species-specific. When forced into contact with termites in the lab, the other two ant species were either not attacked, or attacked in a wholly different manner. But since the ants avoid the termites in nature, it is only these types of forced interactions that can shed light on what is, or what was, going on between these two species. We hypothesize that this interaction is a rare example of an arms race that has actually been won. The termites have evolved a defense so effective that the army ants have essentially surrendered, and now are in a constant state of retreat. But how is this possible, based on our model of predator-prey oscillations? The answer, of course, is that the model is too simple for most systems in nature. Army ants are not entirely reliant on termites. They are generalist predators. So when they cannot consume termites, they can switch to other prey. The resultant asymmetrical arms race is an example of the life dinner principle. Essentially, the pressure of natural selection on the prey is more intense than it is on the predator. For while the ants are fighting for their dinner, the termites are fighting for their lives. In this way, selection pressure may push the prey to evolve such an effective defense that for the predator, avoidance becomes the best strategy. Thus, the interaction between these diminutive insects may simply represent the ghost of predation past. If so, we naturally ask, how common is this phenomenon? How commonly do prey species win an arms race against a generalist predator? The clues, traces of an evolutionary past, are hidden in interactions we almost never see in nature. Once again, we are reminded that the ecological relationships between animals are not always reducible to simple models and equations. Nature is a vastly complicated system, and the driving forces of evolution must always be understood in the context of its complex history.